right. Welcome to Monday's class again. A little bit of a bumpy start, but we're back. As you've probably heard, you know that there's a return. School is semi-resuming on Monday, June 1st. That will not affect what we're doing in class, though. You're going to stay at home. We're still going to be streaming our classes. If there's a need for you to see a teacher or to come into school, then you just make an appointment and you can do it that way. The teachers are returning to school, but students are not. So really nothing changes much on your end. But stay tuned. I think we had a meeting this morning. We're going to have another meeting this afternoon with staff. So I'll probably be able to give you a little more info even tomorrow. All right, I'm going to start lesson 2. So lesson 2 on probability. So far, I think it's been going pretty smoothly, the probability unit. We just did some basic concepts last week. Today we're talking about applications. So applications means usually in math, word problems. So the problems involve some more words, not so maybe just simple, straightforward topics like we discussed last week. Once again, why do we study probability in math class? Applications of probability are found in situations involving medications, warranties, insurance, lotteries, weather predictions, vehicle recalls, games of chance, etc. So let's take a look at example 1. A 20-sided die is rolled. Now our die are 6-sided, but 20-sided die are common in some role-playing games and any games where you have to have more than a 1 in 6 possible choice. So a 20-sided die is rolled. That means there's 20 different sides to this die, and each side looks like it's a triangle in shape. And there's a number printed on the sides of the die. State the probability of rolling a 19 or a 20. Okay, the common notation for stating the probability of rolling a 19 or 20 would be P 19 or 20. I already started using this notation in the first lesson. So I would record my answer as the probability of rolling a 19 or a 20. Well, how many sides have the number 19 or 20? 2, right, out of a total of 20. So that's just review from, basically it's review from last week, right? The bottom number is the total number of what we're looking at. So in this case, it would be total number of sides on the die. And this is the number of sides, not the total number, but the number of sides with a 19 or a 20, right? There's one side with a 19, one side with a 20, so 2 altogether. A percent or a decimal, you can just leave it as a fraction. Remember, we have the 3 main forms of probability that we're going to be using. Fractions, decimals, percents. We spent a fair bit of time in the first lesson working our way back and forth between those 3. So I can just leave my number as a fraction. Using the same 20-sided die, determine the probability of rolling a 5 or less. All right, probability of 5 or less than 5. Well, what does that give me? That gives me the digits 1, 2, 3, 4, or 5. So that would be 5 out of 20. And that's it. So pretty straightforward. In a school, there are 215 males and 258 females. One student is selected at random. All right, state the probability it's a male. All right, so I'm going to follow my definition of probability. So how many males do I have? 215. So my top number is the number of males. And remember what our bottom number has to be? The total number of, oops, I have to add that word total. I'm going to stress that word should be total. Just going to erase this. Whoops, yikes. Trying to make it nice. And, okay, so the bottom number is always the total number of whatever we're talking about. So what are we talking about in this case? Students, total number of students. We're not talking about just males and females for the total. We're talking about the total number of the articles in question, total number of students. Okay, well, we weren't given that directly, so what do we have to do? I have to add up my 215 plus my 258, and that's going to give me, use my calculator, so I get 473. Right, so that's my bottom number. So the probability of it being a male that you just randomly select, and I guess you would just, I don't know, put all their names in a big drum and choose a name, or get the computer to randomly pick a student number, and that would be the probability. All right, let's keep going. Example 4, state the probability of choosing the letter T from the letters in the word statistics. So again, I guess I'm assuming that all of these letters were cut out individually and just thrown into a big drum, and someone just reached their hand in, blindfolded or not looking, and pulled out a number, or pardon me, pull out a letter. So I want the probability of selecting the letter T. Okay, so what do I need then? If I use my definition, this should be the number of T's, and this is the total number of letters. All right, so how many T's are there? There's 1, 2, 3. So there's 3. And the number of letters in total in this word, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 out of 10. 3 out of 10 letters are T's. Therefore, if I just blindly reach my hand into a bucket with all the letters cut up and put in them, then I have a 3 in 10 chance of pulling out a T. Let's take a look at example 5. Random testing of cell phones shows that 2 out of every 500 are defective. State the probability of a randomly selected cell phone not being defective. Okay, they're trying to trick me a bit. So the probability of not defective, all right, once again, let's just kind of set things up here. This top should be the number of not defective phones. I'm going to highlight that. And the bottom number will be the total number of phones. Well, they're saying that the whole group of phones we're talking about is 500, right? Now, if 2 of them are defective, that means 498 should be not defective. And I can move to the side here. 500 minus 2 equals 498. These are the not defective, because these are the defects, the ones with defects. Okay, so that's another example of that word complement that we learned last week. If I know that 2 of them are defective, then the leftover amount is the complement of that. 498 are not defective. All right, let's take a look at example 5. If the cell phone company manufactures 10,000 cell phones, determine how many you would expect to be defective. All right, well, let's think about this. We've done similar things like this in previous units. If I write down just what I know, what do I know right now? 498 out of 500 are defective. And I want to know how many out of 10,000 are defective. Well, I could do a proportion, right? Like a cross multiply technique that we've done before. So these are defective and these are the total number. What if I want to change that to, if I don't want the total number to be 500, but I want the total number to be 10,000? This is my new total number. So I want my new number of defective. So I have 498 over 500 equals X over 10,000. So how we do the cross multiply, if you remember again, we multiply the numbers on the diagonal and divide out the leftover number. We've done this before in previous units, so I'll have 498 times 10,000 divided by 500. All right, let's see what that gets us. They just wanted to shift the total number, right, to increase the total number. So the number of defectives is also going to increase, and we can just set that up using our familiar cross multiply technique. So I get 9,960. Okay, so I would say we would expect 9,960 to be defective. Uh-oh, I just goofed that up, didn't I? This is not defective. To be not defective, sorry about that. Kind of did this the backwards way, right? So I should have used the 2, right? For defective, yikes. So 10,000 minus 9,960, 40 are defective. Sorry, in my cross multiply, I used the not defective number, right? Number not defective. But they asked for defective. I thought it was not defective. Okay, so only 40 are defective. Again, I solved for the not defective because I didn't read the question properly, I guess. So if these are not defective and there's 10,000 in total, we just do a subtraction and that will give you the number that are defective. Okay, so yeah, once again, our cross multiply technique comes into play. We've used that over and over. I think that's it for examples. And again, once you understand the definition of probability, quite often the questions are just you gathering the data from the information and recording the correct probability. So let's take a look at the first set of questions. Maybe let's just do the first 3 together. Okay, so I'm going to give you a little bit of time. I'm going to give you 5 minutes or so. I want you to try to do number 1 and take a look at number 2, and I'll kind of look at the clock and I will give you 5 minutes or so, and then I'll go over the first couple of questions with you. Okay, I'll give you a few more minutes. You've probably finished number 1, but I'll give you a few more minutes to do number 2. Oh, Cynthia, that's a great way to do it too, to think of it. If you can look at the chat and look what Cynthia wrote down, an alternate way, you say not as relevant, but fairly straightforward. I think it's very relevant. If 2 out of 500 are defective, there are 2 500s in every 1,000 and 10 1,000s in 10,000, which comes to 40 as well. That's a brilliant way to do it. It's awesome. It's a much more straightforward way to do it. All right, let's take a look at number 1. 12 horses were entered in a race. If they all have an equal likelihood of winning, state the probability that one of the horses, American Pharoah, wins. All right, if they all have an equal likelihood of winning, state the probability that one of them wins. All right, we're just looking at this American Pharoah. So probability that American Pharoah wins. I think that is the name of a Kentucky Derby winner. All right, so how many American Pharoahs are there in the race? Well, obviously just one, and 12 horses in total. So that's it. That's all it would be. So hopefully these techniques are becoming a little more familiar to you, how to lay out, how to state that you've solved a probability and how to lay out your answer. Use the chart below to answer the questions which follow. And they've kind of given you a big hint here, right? There are 450 students in total. If they didn't give you that, you could easily calculate how many students there are in total, right, by adding all these up. Let's just double check how they got that 450. Whoops. So they would have added all the boys, all the girls. So 60 plus 50 plus 45 plus 55 plus 75 plus 60 plus 55 plus 50. And there I get my 450, right? Now, pay attention to that because they might not always be that nice to you and give you the total right away. If one student is chosen at random, state the probability that the student is in grade 10. All right, so I'm going to just record my answers here. So the probability the student's in grade 10. Let's see, I have to find my total number of grade 10 students, right? So the total number of grade 10 students is 50 plus 60 is 110. 110 students in grade 10. Okay, so I have 110 students in grade 10, 450 in total. Right. Let's take a look at B. So the probability that a student is in grade 12, well, we have to do the same thing, right? 55 plus 50 would be 105 students in grade 12. So I have 105 out of 450. Probability that it's a boy. Let's see. I guess I have to add all these up, right? So 60 plus 50 plus 45 plus 55 is 210. So there's 210 boys in total. So the probability that it's a boy would be 210 out of 450. And then D, the probability it's a girl, well, let's see, how many girls are there? I can add them up, or I could just subtract 450. So if I add all these up, I get 240 girls. Okay, probability it's a girl. Now this is showing your work, right? I'd prefer if you did this, did your capital P and whatever you're looking for equals, and then record your proper fractions, right? 240 out of 450. And then finally, probability that it's a grade 11 boy. That's very specific. So how many grade 11 boys? Well, 45. Okay. So that's that. Let's take a look at number 3, and then I think I'll let you try to work through a few more of these on your own today. They've got a picture of a spinner, right? This is commonly found in board games and stuff. Instead of, if you don't have a die, sometimes you spin a spinner like this. and it determines how many spaces you can move. It says a spinner is divided into 8 equal sections and labeled as below. So we've got 3, 7, 5, 2, 1, 5. There's another 5 there, another 2, and a 6. So pay attention, they're not numbered 1 through 8. Not all the numbers are represented from 1 through 8. There's 2 5s and 2 2s, so some numbers are skipped. A spinner is spun once. Determine the probability that the spinner will land on an odd number. All right, let's do some definitions here. Excuse me. Odd numbers are the numbers okay, they're 1, 3, 5, 7, 9, etc. I don't have to go any further. They start at 1 and they go up by 2s, right? So which are my odd numbers? I'm going to say this number is an odd number. 1 is odd. 5 is odd. And 7 is odd. And 3 is odd. And 2 and 6 are even. So how many odd numbers do I have? The probability that it's an odd number equals 1, 2, 3, 4, 5. 5 out of 8, right? They said there's 8 sections. And even if they didn't tell me, it's easy enough to count 1, 2, 3, 4, 5, 6, 7, 8, 8 wedges. All right, let's try this one. B. The probability that it's a number less than 4. Less than 4. Okay, so which ones are less than 4? 1, 2, 3, 4. There's 4 of them. Probability that a number greater than 9, this is the greater than symbol, by the way, greater than 9. Well, 0, right? There are no numbers greater than 9 represented on the options. Let's do D. A number probability divisible, which means divides by 2. That's another way of saying an even number, right? So how many of these would divide by 2? So let's see. Well, 2 divides by 2. 2 divides by 2. And 6 divides by 2, right? Those are all the even numbers. That's another way of saying divides by 2. So that's going to give me 3 out of the 8. Finally, the probability that it's a mode. Well, we discussed that in the stats unit, right? The mode is the most repeating. So I think there are 2 modes, right? So again, the definition of a mode is the digit that is repeated the most. Oh, sorry. Move it down or up? Down, this way? Thanks. Hang on, I'm going to do this. Is that better? Let me know if that's better, Cynthia. So the digit that is the most repeated. So we've got 2 2s and 2 5s. We have, sorry, up this way. Okay. We have 2 2s and 2 5s. They are both modes then. So the mode is only the digits that repeated the most. So because we have a tie here, they're both modes. So let's see. Probability that it's a mode, well, that would be 1, 2, 3, 4. 4 out of 8. Okay. So not only is this a 5, but this is a mode, 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 and mode. So that was sort of a few definitions here. Standard. So last one, the probability it's a prime number. Now they do give you a little definition here. A prime number is a number with exactly 2 factors, itself and 1. So just to give you a little more, this means only 2 numbers divide evenly into a prime number. They're sort of like the not friendly numbers, meaning there aren't a lot of numbers that divide evenly into it, only itself and 1. So let's take a look. And it's got to be exactly 2 numbers that divide into it. So 7, the only 2 numbers that divide into 7 are 7 and 1. So that's a prime number. 5, the only numbers that divide into 5 are 5 and 1. Now 2 is interesting. There's only 2 numbers that divide into 2. 2 and 1, so it's prime. 1, there's only 1 number that divides into 1 itself, so it doesn't qualify right as prime because I need 2 numbers that go into it. We've already said that 5 is prime and 2 is prime, we said. 6 is not prime, right? Because we have 6 divides evenly by 3, 2, 1, and 6. So it actually has 4 factors, right? 6 divides evenly 1 and 6, but also 2 and 3. So it's definitely not prime. And 3 is prime because the only numbers that divide into 3 are 3 and 1. Right, so how many prime numbers do I have? 1, 2, 3, 4, 5, 6. 6 out of the 8. So quite a few of them are prime. Okay, so that's the first few questions. I definitely wanted to go over and just go over some of these definitions because I know you probably haven't seen some of these in a while. I'm going to give you the rest of the class to keep working on page 9. There's lots more questions. We'll go over a few of these tomorrow again. I'll post the notes. So take care, and I will talk to you later. And Cynthia, I said I was going to have something new for you, and I have another meeting right after class. So I can't meet with you today, as it turns out, but I'll be meeting with you tomorrow, maybe, if you can make it. And I want to set you up with something else that might help you with your Red River stuff. But we're having another meeting. We had one this morning. We're going to have another meeting shortly to discuss going back to school next week. Okay. So I will talk to you or see you all either through email, or I will talk to you tomorrow.